There is a distance in space that almost everyone believes they understand, and that confidence usually disappears the moment real numbers enter the conversation. We say the moon is close, Mars is far away, the stars are unimaginably distant, and somehow our minds quietly arrange those places into a map that feels continuous. It is a comforting picture, but it is deeply misleading. The greatest gap in your mental model of the universe is probably not between galaxies or even between stars. It exists much closer to home, hidden inside a distance so enormous that your brain quietly compresses it until it no longer resembles reality. The solar system does not begin to feel real until you stop thinking about planets and start thinking about the emptiness between them. The moon orbits Earth at an average distance of about 384,000 kilometers, a number that already sounds enormous until Apollo photographs show both worlds fitting into the same frame, making the journey seem surprisingly manageable. That illusion does not survive scale. If Earth were the size of a marble, the moon would still be more than a meter away, while the sun would sit hundreds of meters from that tiny marble, with every planet separated by vast stretches of almost nothing. The solar system suddenly stops looking crowded and begins to resemble isolated islands floating in an endless ocean. That feeling becomes impossible to ignore once spacecraft enter the picture. Every mission sent toward another planet spends months, sometimes years, crossing regions where almost nothing happens. Voyager left Earth in 1977, faster than any previous spacecraft, and after nearly half a century, it is only beginning to move beyond the sun's immense sphere of influence. One mission has lasted longer than many human careers, yet another star remains unimaginably far away. The silence between destinations is the real story. The planets themselves are only brief interruptions. Our intuition is made even less reliable by the diagrams we have seen since childhood. Textbooks almost always enlarge planets while shrinking the distances between them, because otherwise the planets would disappear into tiny dots separated by blank pages. Those illustrations are useful, but they quietly replace emptiness with convenience. Another observation changes the picture again. The average distance between Earth and the Sun is about 150 million kilometers. The universe isn't just filled with objects moving through space. Space itself is expanding. This isn't an explosion of particles flying outwards from a central point within the universe. It's something far stranger. The universe shifts its scale. Therefore, there's no single answer to the question of the furthest place. There are different types of distances. The distance light traveled, the distance the object is from us today. Each tells a different story, and the answer changes depending on which question we ask. The mystery deepens when we look at the oldest light we can detect, the cosmic microwave background. Before stars and galaxies existed, the universe was a hot, dense ocean of particles. Light didn't move freely because it was constantly scattered. Each photon was trapped in a universe so crowded and energetic that it wouldn't let light escape. The universe was like a fog that enveloped almost everything. Then, about 380,000 years after the beginning, everything changed. The universe cooled enough for atoms to form, and suddenly light could travel through space. That ancient light has continued its journey ever since. Today, we detect it from all directions as the cosmic microwave background. At first, we seem to have found the ultimate boundary of the universe, a final wall beyond which no telescope can see. But that idea is wrong. It's not a boundary in space, it's a boundary in time. We're not seeing the boundary of existence, we're seeing the earliest moment from which light could escape. There are almost certainly more universes beyond that horizon. We just can't observe it with the light from that period because the universe was once opaque. The boundary isn't created by a physical boundary, it's created by the universe's own history. This has changed the way we think about the observable universe. It's not a giant sphere with the Earth at its center. Every observer has their own observable universe. Even if you travel billions of light years away, your perspective on the universe will center around your new location. The horizon moves with you. This means there isn't a single vantage point from which the entire universe can be seen. Wherever in space, every civilization would have its own cosmic horizon. Some regions could be visible to one observer while remaining forever hidden from another. In the same universe, two civilizations could exist separated by vast distances, each looking outward and seeing entirely different histories. The universe becomes even stranger when we ask a simple question. If the universe is about 13.8 billion years old, how can the observable universe be around 46 billion light years wide? Shouldn't light only have had 13.8 billion years to travel? At first, this sounds impossible. The answer comes from the expansion of space itself. Nothing is breaking the speed of light. Galaxies are not flying through space faster than light. Instead, the space between them is stretching. The universe is not moving objects apart inside a fixed room. The room itself is changing. Because of this, some galaxies we see today are much farther away now than the distance their light originally crossed. Their ancient signals started a journey when they were much closer, but the expanding universe continued changing around them. Some of those galaxies may already be beyond what we can ever reach. Their future light might never arrive because the expansion of space carries them away too quickly. The universe has places that are unreachable not because we lack better technology, but because reality itself prevents the message from arriving. This idea changes the meaning of exploration. We are not simply traveling outward. We are looking backward through time, reconstructing a universe that is always changing. Every telescope is not just a window into space, it is a machine that looks into history. Every measurement tells us not only where something is, but what the universe was like when that light began its journey. The search for the farthest known place is therefore not just a search for a record-breaking object, it reveals the limits of our own assumptions. Every new observation forces us to question the simple pictures we create in our minds. The farther we look, the more familiar words become unreliable. Distance is not always a simple number. An edge is not always a location. The visible universe is not the entire universe. The most distant place we know is not a place at the end of everything. It is the boundary of what information has had enough time to reach us. Perhaps that is the most surprising part. The universe is not hiding its secrets behind a wall. It is hiding them behind time. If we can be so wrong about something as basic as what far away means, how many other things feel obvious only because we have never looked far enough to discover that they are not? Maybe the greatest discoveries are not waiting at the edge of space, but at the edge of our own understanding. The universe does not simply challenge what we know, it challenges the assumptions we never realized we were making. Every time we look deeper, reality seems less like a place we are exploring and more like a mystery slowly teaching us how little our intuition can truly predict.